My name is Jeff Heinz. I'm in the Department of Linguistics, and I joined the IACS in 2017. Linguistics is the scientific study of language, and so I think it's important to reflect a little bit on the role language plays in daily events in our lives. It's something we do so easily, speaking and listening to each other, and understanding each other, at least most of the time. Think of the emotion, information, humor, and subtleties we convey with language. Despite the progress in language technology over the past decade, it's also something not easy for machines and computers to do well. You can't have a conversation with Siri or Alexa like you do with your friends and colleagues. Still, every typically developing human child will generally master speaking and listening to a language more or less within 3 to 4 years of age. Psychologists and linguists have said the acquisition of language is more like the growth of a blooming flower than how we learn to read or how we learn to add and subtract numbers. So I'm deeply interested in the kinds of computations that underlie our knowledge of language and the kinds of computations by which we acquire that knowledge. My recent work looks at functions over sequences. Sequences are everywhere in language. Sentences are sequences of words, and words are sequences of sounds or signs. A lot of our linguistic knowledge can be thought of as a function from one sequence to another. So for example, in English, we make the plural of a noun usually by adding a Z sound, changing boy to boys and dog to dogs. Not always, of course. The plural of woman is women, for instance. But the general rule in English is to add Z. In Indonesian, you generally duplicate the noun. So woman is wanita, but women is wanita, and flower is bunga, and flowers is bunga. What kinds of transformations are these plural formation rules? What kind of function is it? What kind of function, for example, is involved in translating English sentences to French, or to Korean, or to Unkachug? In mathematics, we have many ways of describing functions over numbers. We talk of linear, quadratic, polynomial functions, trigonometric, exponential, continuous functions, step functions. We have such a rich vocabulary regarding the kinds of functions that exist over numbers, and we know so much about them, how to differentiate them, integrate them, find inverses, and so on. The study of functions over numbers began thousands of years ago with many breakthroughs in the past few hundred years. But the study of functions over sequences only began about 100 years ago, and much less is known. So with my students and colleagues, I work on the mathematical and computational foundations of functions over sequences, how such functions can be learned from examples, and study which of these function classes tell us something about human language.